Suppose we have a triangle, and this is a point chosen on this side and connected to this vertex like that. Today we're going to discover what the sine law is going to give us if we apply it to this triangle and this triangle. I'm denoting this side by A, this side by B, this angle alpha and this angle beta. I'm denoting this side by M and this side by N, and this angle by X and this angle by Y. And let this angle here be delta, then this angle is 180 minus delta. And this side here, the blue side, is D. So applying the law of sines for this triangle, we get this equality, and applying it for this triangle, we get this equality. We take these two equalities and we divide one by the other so that d can cancel out, and then the result is that sine x divided by sine y equals m divided by n times sine of alpha divided by sine of beta. Now I'm going to apply the sine law again for this triangle and this triangle, but this time with respect to other sides and angles. So sine of x divided by m equals sine of delta divided by b, which is here. And analogously, sine of y divided by n equals sine of 180 minus delta divided by a. But we know that sine of 180 minus delta equals sine of delta, so we can write this expression like that. And now by taking this equality and dividing one by the other so that sine of delta cancels out, we get that sine of x divided by sine of y equals m divided by n times a divided by b, which is written here. And this is not really surprising, since from here we know that sine of alpha divided by sine of beta is a divided by b from the law of sines applied to the whole triangle. So this equality actually follows really easily from this one. We can rewrite this equality like that, and rewrite this equality like that. If you wish, we can extend the brother and sister and wife and husband analogy to this case as well. For example, look at this equality here. Suppose that X is a woman married to the man M, and Y is a woman married to the man N, and X and alpha are sisters, and Y and beta are also sisters. Here, above the fraction, we have sine of X, and below the fraction, we have sine of Y. And here, above the fraction, we have all the good friends of X, and below the fraction, we have all the good friends of Y. So M is a husband of X, and so we put it here, and alpha is a sister of X, and so we put it here. N is a husband of Y, and so we put it here, and beta is a sister of Y, and so we put it here. Similarly, if we look at this expression, and suppose that M and B are brothers, and N and A are brothers, then M divided by N, which is here, is a fraction, and on the top side of the fraction, we put all the good friends of M, which are his wife, sine of X, and his brother, B. And on the bottom side, we put all the good friends of N, who are Y, so sine of Y, and A, the brother A. Now take a look at this expression here. So we have M divided by N. Then here we put sine of X divided by sine of Y, so the wife of M on the top of the fraction, and the wife of N on the bottom of the fraction. And then we have sine of beta and sine of alpha. But alpha and beta are not really related to M or N. You can think of it as in this triangle, M and alpha are not related in any way, so they're not really good friends. They don't have such a great relationship. So it wouldn't be a good idea to put M and alpha on the same side of the fraction. So we put it on the opposite side. Alpha goes on the bottom while M is at the top. And you can apply the same logic here. We have sine of X divided by sine of Y, so this divided by this. And then we put the two husbands, M divided by N, like this. And then we have A and B, but how do we put A and B? Well, for example, A and Y don't have a really great relationship because in this triangle, they're not a brother and a sister, and they're not a husband and a wife or anything. And so A and Y are generally in opposite sides of fractions. So because sine of Y is on the bottom side, then A is on the top side. Well, let's see what happens when this point doesn't lie on the segment itself, but it lies on the line, maybe somewhere in the extension here. So this is the situation where this point now lies on the extension of this side, and then this is D, this whole angle here is X, and then this small angle here is Y, this whole segment here is M, and this small segment is N. Now let's apply the law of sines for this triangle and this triangle, and calculate sine of X divided by sine of Y. So sine of X we can find from the sine law for the large triangle, and then we get M times the sine of alpha divided by D. So M times sine of alpha divided by D. Now from the law of sines for this triangle, we know that sine of Y equals N times the sine of 180 minus beta divided by D. But because here sine of Y is in the denominator, we reverse the fraction, and then we get D divided by N times sine of 180 minus beta. Now D cancels out, and sine of 180 minus beta, we know, equals sine of beta. And so this is the final expression we get. From the sine law applied to this triangle, We know that sine of alpha divided by sine of beta equals a divided by b. Therefore, this expression can be rewritten like that by replacing this fraction by a divided by b. Now we can take these two equalities and rewrite them in terms of m divided by n, and then we get these two equalities here. This is the optional problem. We have a square, this is the diagonal of the square, and a point is chosen on this diagonal such that this length is a and this length is b. And also we know that if we connect these points like that, this angle is alpha. We need to prove that the tangent of alpha is a divided by b. And here's the solution. Suppose the side of the square is x, then this side is also x, and if this angle is alpha, then this angle is 90 minus alpha. And now we can apply the sine law for this triangle and this triangle to get the ratio of this sine to this sine. We get that sine of alpha divided by sine of 90 minus alpha equals a divided by b times x divided by x. But the two x's cancel out, so we get that sine of alpha divided by sine of 90 minus alpha equals a divided by b. And now, is this the tangent of alpha? Oh yes, because sine of 90 minus alpha equals cosine of alpha, and sine of alpha divided by cosine of alpha equals tangent alpha. And therefore, tangent of alpha equals a divided by b as desired.